Rochelle, this is just one data point in a mountain of attempts to gradually improve communication. So we spoke earlier today, aiming for within a couple of hours to produce a cogent, directed YouTube, which doesn't communicate to a broader audience, but communicates to you the basic ideas. And so in a little while you'll see through a little PowerPoint, which I'll talk about the idea of. This is a project, a space project to teach the dimensions of space globally. It's a big thinking project globally, but first I'll put it in a strategic framework. So as I said, strategically I'm sort of rehabbing without any particular support. So I've built a structure which is projects, that is projects that people have deemed are not doable or not interesting, but are still worthwhile by my analysis. Communication, which is the art of getting an idea across succinct with all the different modes. Sort of that's the speed, the media, the general idea, and simplifying the idea. The skills, again, it sort of overlaps. It's the skill of actually being able to put this together and produce it. So the actual production skill, but the technical skill of putting it across. And the third area is health. So integrating all those together. Now, unlike a external, so there's a possum or something like that going around here. This is in the school ground late at night. Great lighting and all that type of stuff as I'm experimenting to go forward. But unlike external projects where it's power based and the person up the top can say, look, I don't understand it, there's these difficulties. I'm not looking at an external outcome, it's the internal capabilities. So the projects are basic things like the Haas pendulum, an Einstein project, various advanced physics projects and maths projects will just get done over time and slowly build up. And like communication, it's not whether the key person at the top can understand, it's whether I can actually build that communication pathway, and skills is whether I judge the skills I'm actually building towards the skills. So rather than an external thing, the objective is not external, it's internal. So it's, I suppose we're looking at, do you understand what I'm saying? Is it going? Is there any pointers? It's all the forces internal to move forward, whereas you've got this containment to stop you moving forward, to get on. So after this we'll hit on to the slides. Okay, this is a quick view of the basic idea. On the left hand panel we have some 5 stars which are visible in the night sky, and to make it simple for kids and mostly adults to understand it, these are called stars which are in outer space. Where are they? They're actually out in outer space, and they have distances in a metricized unit of a petameter, which is, as written down there, as the asterisk distances from the Earth's in trillions of kilometers. Indeed, any difference from what people are used to in terms of the km instead of a pm is too hard for them, and so we've made it rather simple, and so it looks as close as possible to a standard distance sign. Now of course we've modified it a little bit because just saying distance signs operate from where they exist, and we've just saying that this exists actually from Earth. It's a bit more important because it's all over Earth. It'll operate anywhere on Earth, but later on we have to look at that. We've got Alpha Centauri, which is 3.69 light years away in the old units, the sort of imperial units. In metric units they're 41 picometers away, so that's the one of the brightest stars in the southern sky, the pointer. And then we have the brightest star Sirius, which kids can easily point to. And then if you can find the Big Dipper, the star below it from Australia, which is red, is Betelgeuse. Now people may know it. Then the blue star to the top of it, the other end, is Rigel. And there's a Chinese named star called Shen K, and different distances away. And the B0 means that it's bigger by multiplying by 10 no times to actually make it the correct size, so that's actual size. Onto the right we have a road map, a road sign showing you distances to tiny star host towns. So they're a host town which have a little tiny star model in them. Of course, it's got here distances to Glenbrook because this would only operate in Glenbrook. And in Glenbrook we have a model of the Sun, a trillion times smaller, and we'll go into that, how big that actually is, but it's actually quite small. The nearest star in this reduced a trillion times down scale. Now again, I'm not teaching about scales because scales is just too complicated for the average person to pick up. That's something I'd like to take on, is in Blackheath. So if you've got a star in Glenbrook, the next star closer to us, it's all empty space up till Blackheath, 41 kilometres away. Avoca Beach is where Sirius is. Betelgeuse is in the Philippines, Japan, Shelbyville, USA, just to say where things are at. So you've got the two signs, and people can be make sense of the two things. It's sort of after trying this over and over again with people just tripping up and not understanding it. So it's a good sort of lab. This is what I'm talking about, errors, helping you close in on it. And come on. Okay, for some reason this is here. This is describing a little bit more about what B12 is. So again, logarithmic 10 times 10 to the raised power, you eliminate a large fraction of your audience. Now the important that you want to get to your parents, grandmothers and people like that who can pick up what's going on without being confused or put across. So logarithmic scales are at the side, and having the word tiny in tiny writing. So if you've got a tiny object, sort of like a Matchbox car, you know, is not the actual car. Matchbox is a code for it, or a Barbie chair you would expect to be the size for a doll, for instance. So the adjective includes what the scaling factor is, and you have to scale it by multiplying it by 10, 12 times, or a million times to get the actual size. And come on, sorry, this is not responsive to me. The tiny sun is 1,300,395,000 kilometers across, and there's 1,000,000 millimeters in a meter, so that's 1.3 millimeters across. And so you've got the crosshairs down here, and that means the sun is, physical model of the sun is the size of a cashew, one of these cupcake fruit things. And so if you've got one that size in your hand, the next white star is this distance away, so it's an important model. And that's to show the distance there with the crosshairs. And here we're going into a bit more. Here on your screen, that little dot on my screen is 1.3 millimeters across. I don't know what's happening to the software here, but the dot is the size of the sun. The idea here is to get feedback, to build internally the basic communication across. The fundamental different idea is where an error for something which has to be produced externally is catastrophic. It's slightly different here. I really feed on errors, and you make little advances here, there and everywhere, and the errors actually come back in and produce forward. So one of the things probably mentioned before is that people really couldn't understand scale or the petameter or anything like that. They couldn't. They immediately shut down. This is the people in the average street going forward, and that's not necessarily a personal error of mine. This is an error within the system, and you go back and you say, well, we can move away from that. So I hope that you can have a look at it. You don't have to give any feedback at it at all. I'm getting all the feedback myself I need just by looking at this and improving it for next time. Thanks again for watching.